Hi everyone, welcome to the session. So this is the first class of binomial theorem. So in this session I am going to discuss the basic concepts of binomial theorem and we'll also solve some concept questions on binomial theorem. Alright, let's begin. Yes, hi Naveen, welcome to the session. Hi Abhinav, welcome to the session. Okay, so let me just introduce myself. My name is Aishwarya and I have done my masters in maths from University of Delhi. Prior to that, I did my graduation in mathematics from Miranda House, University of Delhi. I have more than 4 years of training experience and I have trained for various exams like CAT, GRE and GMAT earlier. Alright, so in this session, I am going to discuss the basic concepts of binomial theorem. We'll also discuss a few concept review questions of binomial theorem. Alright, let's begin. Yes, so now I'm going to give you some information about the Plus and Iconic subscriptions. So if you go for the Plus subscription, you will have access to the classes from India's top educators. All the classes are live and interactive, so you can get your doubts clarified within the session itself. You will also have access to the courses and PDFs would be given to you after the end of each and every lecture. You will also have access to the live mock test and quizzes that happen on the platform. So along with this, we have one more kind of subscription, that is the Iconic subscription. So in the Iconic subscription, all the benefits of Plus subscription will be there. And along with that, you will get personal guidance from your educator. OMIT's preparation is there. You get expert guidelines about GDPI, and if you have any MBA related query, it is resolved by our experts. Also, test analysis of each and every mock test that you give on the platform will be shared with you. Okay, so now these are the prices of our subscription. So the price of Plus subscription for 24 months is 32,800 and for 12 months this price is 22,550. Likewise, the price of Iconic subscription for 24 months is 67,000 and for 12 months this price is 39,500. So over this fees, you guys can get 10% off if you use the code AAISH10. Alright, let's begin. Okay. Yes, can you guys type a hi in the chat box so that I can know who all are attending the session? Yes, hello Naveen, welcome to the session. Hi Vishnu. Hello Supriyo. Okay, alright guys, let's start. So first of all, let us understand why do we need binomial theorem. Okay, let's see. So suppose if you have to find a plus b whole square, we have an identity for this. We have learnt an identity in algebra. It is a square plus 2ab plus b square, right? Likewise, we have an identity for a plus b cube. Okay, but why these identities are important? Now you guys know that these identities are very important in solving a lot of questions. Suppose if you have to find the value of 99 raised to the power 2. Okay, you can find it. 99 in 99 can be done. Okay, this will require some time, but this can be done easily. But what if you have to find the value of 99 raised to the power 7? Okay, so this will take more time. So if you use binomial theorem, doing such calculations become easy. Okay, so this is an easier way to expand a plus b raised to the power n, where n is an integer. Okay, like here a plus b is raised to the power of 2. Here a plus b is raised to the power of 3. Alright, likewise if you have to find a plus b raised to the power 100, so then also you can find this using the binomial theorem. So this is why understanding and studying binomial theorem is useful. Alright, I hope this is clear. Now let's see what is binomial theorem. Let us understand what binomial theorem is. So what is a plus b raised to the power 0? This is 1. If a plus b is not equal to 0, then this value is equal to 1. Likewise, a plus b raised to the power 1 is a plus b. A plus b whole square is a square plus 2ab plus b square. Likewise, we have a plus b whole cube, a cube plus 3a square b plus 3ab square plus b cube. Likewise, we have the formula for a plus b whole square, a plus b raised to the power 4. Okay, so continuing this pattern, you will be able to find the value of a plus b raised to the power n also. Okay, so this expansion of a plus b whole raised to the power n is given by binomial theorem. Why binomial? Bi means 2. Okay, and here there are two terms, a and b. That is why this is known as binomial theorem. Okay, let us continue further. Now let us understand what is binomial theorem. So this is your binomial theorem. Okay, now the expansion of a plus b whole raised to the power n is given by. So we use this formula for combination here. Okay, so this is the formula for selection here. So I am going to use this formula that NCR is equal to factorial n upon factorial r into factorial n minus r. Okay, so are you guys aware about this formula NCR? Is this formula clear? Yes, please give me a thumbs up if this formula is clear to everyone here. Hi Praveen, welcome to the session. Yes, is this formula clear? The formula for NCR, when you have to select R objects out of N objects. Okay, so this is the formula for NCR. Let's see how we are going to use this formula here. So this N is actually the value of A plus exponent of A plus B. This is your N. Okay, so now I am going to change the value of R from, so R will vary from 0 to N. Okay, let's see how. So first I am going to take R as 0. So if I take R as 0, I will get NC0, okay, A raised to the power N. Alright. Yes, hello Shalu, welcome to the session. Okay, let's see the second term. So the second term will be, now I am going to take the value of R as 1. So this will be NC1. Now A will be decreased by 1 power. So this will be A raised to the power N minus 1. And B will be increased by 1 power. So B will be B raised to the power 1. Likewise, next time I am going to take the value of R as 2. So therefore the next term will be NC2 into A raised to the power. Now I am going to decrease N again by 1 unit. So this is N minus 2. B will increase by 1 unit. So this is B square. Okay. So likewise the terms will continue and the last term will be NCN. When the value of R would be equal to N. Okay. The value of A would be 0 now. This would be N minus N and the value of B is N. Okay. Yes. Is this formula, is this theorem, binomial theorem clear to you? Is this expansion clear to everyone here? Yes, guys, please write a yes or okay in the chat box so that I can know who all are attending. Sorry, so that I can know if you are able to understand this. Yes, Naveen, Vishnu, Supriyo, Praveen, is this clear? Yes, yes Rani, definitely I can repeat it again. So see, this is the expansion of A plus B raised to the power N. Okay, this is the expansion of A plus B raised to the power N. Now, if, so I am going to use this formula NCR. Okay, the formula for NCR is factorial N upon factorial R into factorial N minus R. Now, this R is going to vary. I am going to change the value of R with each and every term. Okay, so I will start with a value of r as 0 and I will move r from 0 to n. Okay, so first I'll take r as 0, then r as 1, then r as 2, then r as 3 till r as n. Okay, now let's see the first term here. We have NC0. So for when r is equal to 0, we get the first term. NC0 a raised to the power n. Okay, now let us take r as 1. So I will get NC1 a raised to the power. Now the powers of a are decreasing by 1 and the powers of b are increasing by 1. So this will become n minus 1 and power of b will become 1. Okay, now when I take the value of r as 2, so this will be NC2, the power of a will be n minus 2 and the power of b will be increased by 1 again, 2. Alright, so this is how the entire pattern will continue. Okay, so all the terms will be like this and the last term will be when you take the value of r as n. So this will be NCn a raised to the power 0 and b raised to the power n. Alright, yes, is this clear now? Yes, Rani, is this clear? Okay, alright. Yes, Mayur, this is definitely safe. Alright, so I would just request everyone to just concentrate on binomial theorem as of now. Okay, yes, okay. Vishnu, Rani, I hope this is clear. Praveen, is this clear? Next one. Okay, so now in the binomial theorem, in this expansion that we just discussed, let us just note a few points. So there are certain points that need to be noted and let us understand these points. First point, the total number of terms in the expansion is always one more than the exponent. Now what do I mean by this? So if I have a plus b whole square, how many terms are there in the expansion? We have a square plus b square plus 2ab. Number of terms is 3. Okay. Now, let's go back and check this point here. When I have a plus b whole cube, then how many terms in the expansion? 4. When I have a plus b whole raised to the power 4, I have 1, 2, 3, 4, 5. 5 terms in the expansion. Okay. So, therefore, I can say that in the expansion of a plus b raised to the power n, the number of terms is n plus 1. Alright, is this clear? Now let us understand the next point. Now see, in this expansion, we are changing the value of r here. Right? Now according to the value of r, the exponents of a and b, this term and this term are increasing and decreasing. Okay, so what happens is that the exponent of a increases by 1, the exponent of a decreases by 1 with each term. Okay, so if it starts with a raised to the power 7, then this is a6, a raised to the power 5, a4, a3, a2, a1 and then finally a raised to the power 0, that is 1. Okay, and the exponents of b will keep on increasing by 1. So this will be b raised to the power 0, then b1, b2, b3, b raised to the power 4, b raised to the power 5 and so on. Alright, so I hope this is clear to you. Let's see the next statement. It says that in each term of the expansion, sum of exponents of a and b is always same and this is equal to n. Okay, let's go back and check. So here we always see this n, n minus 1, n, n minus 2. So the sum of exponent of a as well as b is always equal to n. Okay, so let's see here. So we have 7 here and 0 here. Let us add these exponents. So again 7. Here also 6 plus 1 is 7. 5 plus 2 is 7. 4 plus 3 7. 3 plus 4 7. 5 plus 2 7. Alright. So the sum of exponent of term A and exponent of term B is always equal to n. Alright. Is there any doubt in your mind regarding these 3 points that we have discussed? If there is any doubt, please feel free to ask. Yes. Praveen, Rani, Vishnu, is this clear? Mayur, is this clear to you? Naveen, is this clear? Yes, guys, please confirm if if the slide is clear to everyone. Okay, all right, let us continue further now. So let us discuss one question. So in the beginning of this session, we discussed that we can find higher parts using the binomial expansion. Let's see how. So this is the first question. So let us do it together. So now see, I can see this 99 as, I can write this 99 can be written as 100 minus 1. Okay, so I can write 99 raised to the power 5 is equal to 100 minus 1 raised to the power 5. Okay, now let's see. According to binomial theorem, we have a plus b whole raised to the power n is nc0, a raised to the power n. Then next term is nc1, a raised to the power n minus 1, b raised to the power 1. Okay, then so on till ncn, b raised to the power n. Right, this is our binomial theorem. Right, so let us try to apply this theorem over here. Okay, so if you compare 100 minus 1 with a plus b, can you guys tell me what is the value of a and what is the value of b here if you compare it with this term? Yes, please tell me the value of a and b. You have to compare it with 100 minus 1. Okay, let's see. So if I compare it, the value of a is 100, but the value of b is not 1. If you see, I have a plus sign here and here the negative sign is there. Therefore, the value of b is equal to minus 1. Okay. Yes, is this clear? Now let us continue forward. So if these are the values, so I am going to put this in the expansion now. So this expansion will be equal to the first term, that is n. Now the value of n also, if you see, the value of n is 5. So the expansion will be 5c0 a raised to the power 5 into b raised to the power 0 first. Okay. Then 5c1 a raised to the power 4. The exponent of a has decreased by 1 and the exponent of b is increased by 1. Okay. Then we have 5c2 a raised to the power 3 b square plus 5c3 a square b cube. Then the next term will be 5c4 a raised to the power 1 and b raised to the power 4. Finally 5c5 a raised to the power 0 b raised to the power 5. Okay, I hope this is clear. So now let's just put in the values here of a and b and let's see what will I get. So I will get this as 5c0. What is a raised to the power 5? 100 raised to the power 5. What is b raised to the power 0? This is 1. Then we have 5c1. What is a raised to the power 4? 100 raised to the power 4 into b. b is minus 1. Okay. Next term 5c2 a cube means 100 cube plus b square, which is minus 1 whole square. Next term 5c3 a square. What is a square? 100 square. Then b cube again is minus 1 raised to the power 3 plus 5c4 into 100 into minus 1 raised to the power 4 plus 5c5 into, now a raised to the power 0 is 1, b raised to the power 5 means minus 1 raised to the power 5. Okay, please simplify this. Yes, please tell me what is the value of 5c0. Let us use this formula. NCR is factorial n upon factorial r into factorial n minus r. Please apply this here. Yes, guys, give me the value of 5c0. Okay, so this will be factorial 5 upon factorial 0 into factorial 5. So the value of factorial 0 is equal to 1. So this and this will cancel off and this will give me 1. So therefore this is equal to 1. Okay, so this you can note that the value of 5's any number NC0 is always equal to 1. Okay, now let us put this value here. So this first term I'll get as 100 raised to the power 5. Second term will be 5c1. What is 5c1? So 5c1, the value of 5c1 is equal to 5. Okay, please verify this value using this formula. Okay, next will be 100 raised to the power 4. Now we have minus 1 here. Hence, this will be equal to, the sign will be changed to negative. So this is minus 5. Okay. Now in the next term, minus 1 is raised to the power of 4. So even power, so this is plus. What is the value of 5c2? The value of 5c2 you can find using this factorial 5 upon factorial 2 into factorial 3. So this will be 5 into 4 by 2, hence 10. So this value is 10 into 100 raised to the power 3. Now again minus here, the value of 5c3. So the value of 5c3 is also equal to 10 into 100 square plus 5c4. So 5c4 is equal to 4. Sorry, 5c4 is equal to 5. So this is 500 plus 5c5 is equal to 1. Okay, fine. But we have minus 1 is raised to the power 5. So negative power, therefore this sign will be negative. Alright, so if you will simplify this, you will get the value of 99 raised to the power 5. Yes, is this question clear? Is there any doubt in this question? If there is, please feel free to ask. Yes, Praveen, Rani, Shalu, Naveen, is this question clear? Mayur, is the question clear to you? Okay, all right, great. So I hope this is clear. Now likewise, so in this question we found the value of 99 raised to the power 5. Here in this question you need to tell me the value of 101 raised to the power of 4. Please try to solve this one. Okay, so this 101 raised to the power 4 can be written as 100 plus 1. Okay. Compare it to a plus b raised to the power n and tell me what is the value of a, the value of b and the value of n. Yes. Yes, Shalu, what is the value of a, b and n? Yes, correct, Prakhar. So the value of a is 100, the value of b is 1 and the value of n is 4. Okay, correct. Alright, so please try to solve this. So you need to solve 101 plus 100 plus 1 raised to the power 4 using binomial expansion. Please solve this and tell me the final value. Yes. Okay. Yes, let us discuss this one. So now, since the value of n is 4, so I'll start with 4c0. Okay. So 4c0 x raised 4c0 now 100. 100 will be raised to the power of, maximum power of 100 will be taken. So 4. Minimum power of 1 will be 0. So this will be 1. Then next term will be 4c1 into 100 raised to the power of 3. Power of 100 is reduced by 1. Power of 1 will be increased. Plus 4c2. Okay, so 4c2 means 100 raised to the power of 2. Again, this term 1. Second term, this is 1 square now. Then next term will be 4c3, 100 raised to the power of 3, and this will be 1 cube. Alright, then finally the last term of this expansion will be 4c4, 100 raised to the power, sorry, the exponents of 100 are decreasing. So this is 100. Okay, so this is 4c4, 100 raised to the power 0 and 1 raised to the power 4. Okay, so finally I'll get what is the value of 4c0. Yes, the value of 4c0, this value is always equal to 1. As I discussed earlier, the value of nc0. Okay, this is always factorial n upon factorial 0 into factorial n. So this is always 1. Okay. So this is 1 into 100 raised to the power 4 plus this is 4c1. What is the value of 4c1? Yes, Prakhar, correct. What is the value of 4c1? Correct. 4C1 is 4 and this is 100 cube. Likewise, the value of 4C2. Please calculate and tell. Yes, Prakhar, correct. Yes, Praveen, Prakhar, please solve 4C2 and tell the value. Correct, 6. So this value is 6. So I am going to put 6 here. So this is 6 into 100 square. Okay, then what is this value? 4C3. 4C3 will be equal to 4. So this is 4 into 100. And then 1. 4C4 is 1 into 1. Okay, so this is the value. Hence, finally our answer is 100 raised to the power 4 plus 4 into 100 cube plus 6 into 100 square plus 400 plus 1. Okay, so this will give us the final answer. So if I solve this, let us try to solve this. Let's see what will I get. So see, solving this is not a very difficult job. Okay, if you have to find this will take a lot of time. Okay, let's see this. So 100 4 times. Alright, so these are the number of zeros. Then 4 into this. Okay, so how many zeros? 6 multiplied by 4. Then 6 into 100 is 2 times. So this is and 6. Alright, then 400, then 1. Let us add these numbers. What will I get? 1, 0, 4, 0, 6, 0, 4, 0, 1. So this is the value of 101 raised to the power of 4. Alright, is this question clear? Yes, is this question clear? Yes. Okay, alright, let's move on. Now, next question of different type. Which number is larger? 1.1 raised to the power 10,000 or 1,000? What do you think? Yes, okay, Vishnu. Yes, please answer this question. Think about it. Okay, 1.1 raised to the power 10,000 or 1,000. Okay. Alright. So, okay. So, you guys think this is the larger one? Let's see. So, let us take this term. 1.1 raised to the power 10,000. Okay. So, can I write this as 1 plus 0.1 raised to the power 10,000? Yes. Is this a step clear? Yes, Sharmishta, Prakhar, Praveen, Vishnu, is this a step clear? That I can write it in this manner? Okay, alright. Now see, Now I have written it in this manner, so I am going to use the binomial expansion a plus b raised to the power n. Now if I compare this to this, so that I will take the value of a as 1, the value of b is 0.1 and the value of n is 10,000. Okay, let us start. So the first term will be 10,000, okay, C0 into, yes, what will be the first term, into 1 raised to the power 10,000, okay, plus next term will be 10,000 C1 into 1 raised to the power, how much? Okay, so this will be 10,000 minus 1. But see, 1 raised to the power anything will always be 1. So we can ignore this for this question. Next will be 0.1 raised to the power of 1. Plus next term will be 10,000 C2, 1 raised to the power something irrelevant because this is 1. Then 0.1 raised to the power 2 and so on. Okay, till 10,000 terms. Let's see what would be the value of this term. So NC0, as I told earlier, is 1. So this term is 1. Now please tell me what is the value of 10,000 C1. Yes, quickly answer, what is the value of 10,000 C1? Yes, guys, value of 10,000 C1. Okay, let's see. See, whenever we have this NC1, let us find its value. So this will be factorial n upon factorial 1 into factorial n minus 1. Okay, so this is equal to n always. Okay, so the value of NC1 is always equal to n. Okay, so using this result here, we can say the value of 10,000 C1 is equal to 10,000. Okay, now then 1 into what? 0.1. So 0.1 plus 10,000 C2. Okay, so rest of the terms. But all the terms will be positive here. This we are sure of. So from here only this will be equal to 1 plus how much? 1,000 plus and so on. Right? So from here we got this value as 1001 plus and so on. Right? So now you tell me which number will be bigger. This number or this number? Which number is the bigger number here? Yes. Let us take this as first. Say second. Which number is bigger? Yes, Prakhar, Naveen, Priyansh, Sharmishta, Praveen, Vishnu, which number is the larger one? Correct. So therefore the answer will be that 1.1 raised to the power 10,000 is larger. Alright. Yes. Is this question clear to everyone? See, so when we look at two numbers, it seems that this one will be bigger. Okay, because ये तो 1 से थोड़ा सा ज़्यादा है, ठीक है, फिर उसके आप कितने भी exponents कर लो, this will still be close to 1, right? This is our way of thinking. Okay, but maths is really beautiful, right? So we can use this binomial theorem, and according to this, you can clearly see that this number is the bigger one. Okay, let's see the next question now. Question number 2. Similar logic, please tell me which number would be the larger. Yes. Okay, I take this number as A and this number as B. Please tell me which number would be the larger one, A or B. Yes, correct, Sharmishta, your answer is right. So this number will be greater. Why? Similar logic as we did in the previous question. So I can write this number. How many zeros here? 6. Okay, so this number can be written as 1 plus 0.01 raised to the power of this. Okay, so now this is 1 plus this number plus and so on. So this term will be 1 upon 100 will also be there. Okay, so I will get 2 zeros will be cancelled off, but I will get 1. Okay, this. So therefore A is greater than B. Alright, similar logic, correct. Prakhar, your answer is right. Let us continue further to the next question. Alright, so this is the second concept I am going to discuss today, the general term of the binomial expansion. Okay, so now you can see that in the binomial expansion, we have a plus b raised to the power n is nc0, a raised to the power n, b raised to the power 0, then nc1, a raised to the power n minus 1, b raised to the power 1, till ncn, a raised to the power 0, b raised to the power n, right? This is our binomial expansion. Now, what if this value is given to be as a plus b raised to the power 100? Okay, and you have to find the 25th term in this expansion. Okay, so finding this by making the complete expansion and then counting which is the 25th term, this will be a very difficult task, right? So that is why you have a standard formula to calculate the 25th term or the nth term, the general term of a binomial expansion. Okay, so here is the formula for that. Using this, you can find the general term of the binomial expansion. Alright, let's see how can you find. So if it is given that you have to find the 25th term. Okay, now since you have to find the 25th term, the general term here is denoted by Tn. So I am going to take this as T25. Okay, now this is R plus 1 and here I have 25. So what would be the value of R here? Please tell me what is the value of R here if I have to find 25th term here. Yes, please tell me the value of R. Correct. So the value of R will be 24. So now I am going to take the value of R as 24 and then we can get the values. We can get the general term here. So this will be NC24 into A raised to the power N minus 24 into B raised to the power 24. So this way you can find the general term of a binomial expansion using this formula. Alright, now let us see the question. So you have this question. In the expansion of x plus y raised to the power 9, you need to find the coefficient of x raised to the power 6 into y raised to the power 3. Okay, so for this I am going to write the general formula here. The general term is given by TR plus 1 is NCR into a raised to the power n minus r into b raised to the power r. This is the general term. Please make use of this and try to solve this. Okay, try to solve this yourself. Try this, and if you need a hint, please let me know if you need a hint to solve this question. Okay, please start. Yes, is the question clear? Yes, Prakhar, Praveen, Sharmishta, is the question clear? Priyansh, is the question clear? Vishnu? You have to find the coefficient. Coefficient means number. So if in the expansion, if you have x raised to the power 6 into y raised to the power cube, y raised to the power 3, so इसके पहले जो number आएगा वो find करना है. Yes, definitely I can tell you how to proceed. So this is the general term. Okay, so first of all, let us write this. This term is written in form of a and b. Let us write it in the form of x and y. It will be more clear. Okay, so from here I can clearly see that n is equal to 9. Okay, a is equal to x and b is equal to y. Let us put it in this formula. Let's see what will I get. So I will get t of r plus 1. Any term that I have will be 9cr into x raised to the power n minus r and y raised to the power r. Sorry, n is 9 here. Okay, so I'm going to put 9 here. Alright, is this a step clear? This one, that this is the form of the general term of this expansion. Yes, Prakhar, Praveen, is this clear? I have just substituted the value of n as 9 in this general term formula. Okay? Alright. Now, you need the exponent of x as 6. Okay? If the exponent of x is 6, it means the value of n minus r should be equal to 6. And the exponent of y is 3. So therefore exponent of y here should be equal to 3. So therefore from here you get r as 3. And this r as 3 is also satisfying this. Right? So therefore we got the value of r here. And the value of r is equal to 3. Am I right? Is this clear? Okay. So now that I know that r is 3, what is the coefficient of this term? It is 9cr. So basically I need to calculate the value of 9cr. Okay. So we get that the coefficient of x raised to the power 6 and y raised to the power 3 is 9cr. Okay. So this 9cr is 9c3. So we just need to find this value. So this value will be equal to factorial 9 upon factorial 3 into factorial 9 minus 3. Okay. Yes, Praveen, I'll share this PDF in the group. What you need to do is that just send in a message there that you need the PDF of this session. I'll definitely share it there. Okay. Yes. So this is 9 into 8 into 7 into factorial 6. Okay. And this is 3 into 2. So this is 6 into factorial 6. So factorial 6 and factorial 6 will get cancelled out. And this will give me now 3 into 3 and 3 into 2 and 4. So we will get this as 12 into 7. Hence this is equal to 84. Alright. So therefore coefficient of x cube into y, x raised to the power 6 into y cube is equal to 84 in the expansion of x plus y raised to the power 9. Alright, is this question clear? Yes, guys, is this question clear to everyone here? Do you guys want me to repeat any question or any concept that we discussed in today's class? If you want, we can repeat that also. Okay. Alright, so I'll share this PDF in the Telegram group as well. Okay. Alright. So this was the last question of today's class. Now this is the information about the batches that are going to start recently on our platform. So recently we are going to start a new batch from 21st of April. Also 2 new batches were started from 14th and 17th of April. You guys still have time to enroll for these batches and start your prep with us. Remember to use the code AAISH10 while taking your Plus or Iconic subscriptions. Now, so these are the students who have more than 99 percentile in CAT 2020. You guys can also join this list for 2021 if you start with your prep as soon as possible with us. Okay. Now this is the scholarship test that is conducted by Unacademy Combat. To unlock this test, you can use the code AAISH10. Okay. Yeah, so this is Ask a Doubt feature of the Unacademy app. Just take the picture of the question you want the solution for and submit it on our platform. As soon as you do this, you just have to take, as soon as you do this, the educators will solve the question and share the detailed explanation with you. Okay, so this is a very good feature of the app that you should make full use of. Okay. Now to take the Unacademy subscription, you just have to install the Unacademy Learning app. As soon as you install the app, just select CAT as your goal and click on Get Subscription. Remember to use the code AAISH10. If you use this code, you will get 10% off the entire course fee for both Plus and Iconic subscriptions for all the months. Okay. Also, you can use this code to unlock my special classes on the platform. Alright, so you can also unlock a lot of free mock tests and quizzes that happen on the platform. Okay, free quizzes and tests can be unlocked using the code AAISH10. Alright, now. Alright, so this is and if you like this video, please share it with your friends also who are preparing for CAT so that they can also get benefits from this. Now this is the name of my Telegram channel. Please subscribe to it to get links of all my YouTube and special classes there. Also, you can share the pictures of the questions you want the solutions for. Alright. Thank you guys. Thank you all for attending the session. Keep practicing. I hope the session was useful for you.